In this example, we're going to use the class pad to explore the shape of the binomial distribution. Now I'm going to start by looking at a binomial distribution with 10 trials and a probability of success of 0.5. Note that that also means that the probability of failure is 0.5. And so we should get a nice symmetrical picture from this first part of the example. Now, the first thing I want is the set of possible outcomes from this particular distribution here. In other words, a set containing 0 to 10, which I could just type in, but we can actually use the features of the class pad to do it. So if I go to interactive and then to list, and what I'm going to do is then go create and sequence, and it brings up this box here. Now my expression, I just want to be x. So I've got the variable x. I want it to start at 0. I want it to end at 10. And the increment is 1. So it goes 0, 1, 2, 3, and so on. And if I press OK, it now gives me a set containing 0 to 10. Now, ideally, I really wanted to store that in a list. So if I just go back here and we press this arrow, that's the store button, and I can just literally type in list 1. And then I'm just going to execute on that. Nothing's changed. It did put this down again, but it happens too quickly to see it. And for some reason, I put zlist1 there. And let's just do that again. And now that would definitely be stored in list 1. Now I want to calculate a set that has the probability from this distribution associated with each possible value of x. And we can use the class pad to do it using functions that you've seen before. So we'll go here, we'll go to discrete and binomial PDF. But where it says x there, what I'm going to do is type in list 1. So instead of putting a particular value of x, it's just going to go through the list and put each value in. We know that there are 10 trials. We know the probability of success is 0.5 in this case. And we press OK, and it's going to give me all of these values. So the probability of x being 0 from this distribution over here is 9.765 times 10 to the negative 4, and so on. You can scroll through that list, but ideally we want that to be in another list. So I'm just going to go back here and let's do a store, and this time I want to go in list 2. So I can literally type in list 2 and execute, and those values are now stored in list 2. Now, in order to graph this, I want to come out of main. So I'm going to go to statistics. And those values should already be here because this is list 1 and list 2. But when I was doing something yesterday, I cleared them out. Never mind. I can type them back in. So list 1. And it imports the values, and then I'm going to put in list 2, and that imports all the values that we had. So these are the possible outcomes for x, and these are the associated probabilities. And now I'm going to click here and select the type of graph I want, which is a histogram. And my X list is list 1. And I'm going to put the frequencies in list 2. And then I'm going to click set. And then all I need to do is press this. Let's make the H step just 1, starting at 0. And we should get a picture of our distribution, which with 0.5 we assumed would be symmetrical, and indeed it is. Now let's suppose that we wanted to look at a different binomial. For example, let's say we go for a binomial 10, but this time let's take it to 0.3, which should be more skewed to the left-hand end. The higher probabilities should be down here, a much lower chance of the numbers closer to 10. So let's see what happens with that. What do we need to do to go there? Well, we can go back to main. We don't need to redo all the steps. We've got this initial set that goes into list 1. And then all I need to do is change the probability just here to 0.3. And then it goes into list 2. We should see those values change, and indeed we did. Now, if I go back to statistics, it should be our new values. And we've still got histogram set. And if I click on this again, let's just change that to 1. I don't know where it suggested 1.12. And here we go. And we can see that it is more skewed. And the values here are very, very low for the sort of 9, 10 values.